I solve quadratic equations using the square root property? So, the two times I'm going to use this, I'm going to use it if there's no x in the problem. So there's only an x squared, but there's no x. So see here, only x squared. For example, 3x squared minus 4 equals 68. So if you only see an x squared and no x, that's a great time to use the square root property. It's going to make it much easier for you to solve that than to try to factor it or something else. Just use the square root property. Or another opportunity to use it is if you see that it has a perfect square trinomial. Because if this has a perfect square trinomial, then you'll see what I can do to then solve it easily. Alright, so we're going to actually solve these two problems so you can see how it would work in both instances. Okay, so here's what we're going to do. So this one right here, what I'm going to do is I want to isolate x. So just like anytime you solve an equation, I'm going to isolate my x squared here. Okay, so add 4. Okay, then I know I would divide by 3. Alright, so far I have subtracted 4 from both sides. I have divided 3 by both sides. So I got x squared equals 24. So then the square root property says I can take the square root of both sides. So that means I'm going to get x plus or minus the square root of 24, but I need to check to see if that can be broken down. And so that can be broken down into the square root of 4 and the square root of 2. So my answer would be plus or minus 2 square root 6. Okay, so those are my two answers. So again, if you remember, the answers to this are the x-intercepts. And so the square root of 24, that's actually a location on the x-axis. So I could estimate that that's a little bit before 5, so it's a little bit before 5 on both sides. Okay, of the y-axis. Over here, how am I going to use this? So the other time I can use this is if I notice this is a perfect square trinomial. So if I see this as a perfect square trinomial, I can just go ahead and turn this into x minus 5 squared equals 27. So that makes it really easy for me because then I can just use the square root property by taking the square root of both sides. So square root, square root. So I know those undo each other, so I get x minus 5 equals the square root of 27. Okay, so now I can break this down. I know that this is going to be plus or minus. So I get plus or minus 3 root 3, and then I need to subtract 5 from both sides. So the way I'm going to write this, because I can't actually subtract 5 because these are not like terms, I'm going to say negative 5 plus or minus 3 root 3. So that would be my final answer. So one of the x-intercepts is going to be negative 5 plus 3 root 3, and the other one is going to be negative 5 minus 3 root 3, which again, if I plugged it into a calculator, I could get an approximate place where that would fall on the x-axis.